I'm going to do a quick run through of how to do the RocketCart Lab. The point of the RocketCart Lab is to determine the the force that is exerted by the fire extinguisher that is inside the rocket cart. So the force that is being used to accelerate the rocket cart. So the first thing, well, here's the video, and Emilio zooms across, and your tools are a ruler and a stopwatch. So the first thing you have to do is develop a method to determine the force exerted by the rocket. And in this space you need to describe your method. I am not going to fully answer this question with sentences and stuff like you should. This is not measurements and calculations, but what you should do, and you should include equations that you'll use. Well, we know that F equals ma, so you're going to determine acceleration using displacement and time. And then, so you need an equation that will allow you to determine acceleration using displacement and time. You also know that initial velocity is 0. You do not know final velocity. So you'll have to look through your kinematics equations for an equation that has initial velocity, acceleration, time, and displacement in it so that you can find the acceleration. You cannot use the definition of acceleration here. You can't use acceleration as Vf minus Vi over t because you don't know the final velocity. And now you'll need to make the measurements and do the calculation. Please show your work here if you want to earn the points. So let's look at what we have. I'm going to pull Emilio back to the beginning. Okay, I'm going to forward this until I'm going to put the ruler so that the front of his toe is at 0. And I'm going to play with it until we get to the point in the video where he starts moving. See, back here he's just stationary, so we don't really care about that part. But I'm going to forward it little by little by little until he begins to move, and he begins to move right here, I think. So I'm going to set the timer at 0, and then if the initial velocity is 0, and he zooms across a distance of 4 meters in a certain amount of time. So there's your displacement, 4 meters. Your time will read here. Make sure that you reset your stopwatch at 0 when you want to start measuring, when he just begins to move. So you calculate the acceleration, and so you show acceleration, calculation, and then force calculation. So you'll calculate your acceleration there, show your work, and then F equals ma. The mass, they don't tell you, you're supposed to ask the teacher. The mass of Emilio and the cart is, I think it's 125 kilograms. Hold on just a second. I can actually show teacher notes. And yes, 125 kilograms is the mass of Emilio and the cart altogether, and so you'll need that. Okay, then you do part 2. This is a graph of force versus time, and this is a device that measures the actual force being exerted by the fire extinguisher, not based on the motion of the cart, but based on just the force exerted by the fire extinguisher. And the first part says, use the graph to estimate the force. Don't just put a number. Tell me how you get a number. Obviously, the minimum force during this time, while he's moving, is about 110, and the maximum is about 140. But it settles into this 110 to 120 range for a good bit of the time. So tell me what you think the average is, and give me a little bit of information on how you find that average. So don't just say 125 newtons. Say, 118 newtons because of blah, blah, blah. So tell me how you got it. Compare this value to what you determined in part 1. So compare the average force here with the force that you got when you did your calculation up here at number 2. They should be similar, but they should not be the same. When comparing means do a percent difference, E-R-E-N-C-E, calculation. So you may need to look up the equation. It should be in your notes from very early in the year, how to do a percent difference calculation, not a percent error, but it's also called relative error calculation, so that you can tell me numerically, give me a number, a percent number that tells you how close these are, or how far apart they are. If they're close, the percent difference will be small. If they're large, the percent difference will be large. I mean, if they're large, but if they're very different, the percent difference will be larger. And then discuss possible reasons. Well, I'm going to tell you a little bit here to give you a shove. The first part, we base our calculation on the motion of the cart. That must take in all of the forces that are acting on the cart, because the acceleration is not just due to the fire extinguisher force, it's due to the total force, the net force acting. So think about all of the forces that are acting. So that you've got friction in the tires, you've got air resistance, you have a whole bunch of drag forces, forces that would slow it down, that are opposing the fire extinguisher force. So the net force is, the force from part one, is all of the forward forces, which is the fire extinguisher, minus all of the backward forces, which would be any frictional forces that come into play. The graph is only the fire extinguisher. So does that information support the difference that you see in your two values, and why? And if I see my own words written here, you're not going to get a whole lot of credit. So I've given you some hints. I hope that you found this helpful.